In this video, we'll look at correcting the timing of a performance with elastic audio. Having the ability to warp and conform an audio clip to match a tempo map or to correct the timing of a performance can save countless hours of work. I'm going to take you through how to enable elastic audio and how to use it to warp and conform audio in your sessions. By enabling elastic audio on a track, you will have the ability to conform audio clips on the track to the session tempo, manually adjust or warp the timing of any portion of the audio on the track, and also quantize the performances that you have recorded. Elastic audio provides track-based time compression and expansion, or TCE, processing, enabling you to quickly and easily manipulate the timing of audio events or beat match an audio performance to follow the session's tempo ruler. Elastic audio can be applied using real-time or rendered TCE processing. Pro Tools' elastic audio processors use high-quality transient detection algorithms combined with beat and tempo analysis to calculate a file's native tempo and determine the file's duration in bars and beats. This analysis involves examining the audio content of the file to identify rhythmically significant audio events. Enabling elastic audio on a track. The first order of business when preparing to use elastic audio is to enable an elastic audio processor on the target track. Any audio track in a Pro Tools session can be elastic audio enabled using the track's elastic audio plugin selector in the edit window. After applying an elastic audio processor, you can choose whether to apply changes in real time or switch to rendered processing mode. All but one of the Pro Tools elastic audio processors use real-time processing by default. Real-time elastic audio processing is immediate, so you can hear the results right away, but it can demand significant system resources when used on multiple tracks. Rendered elastic audio processing is non-real-time, meaning that you may have to wait for the results to render to disk prior to playback. The benefit of rendered mode is that it is less demanding on resources. If your system cannot keep up with the demands of real-time elastic audio processing, Pro Tools will display a message suggesting that you switch to rendered mode. To enable elastic audio on a track, first create a new audio track or choose an existing audio track. Click the track's elastic audio plugin selector in the edit window and select the appropriate elastic audio plugin from the pop-up menu. Any audio clips on the track will temporarily go offline while elastic audio analysis is being performed. The waveforms will appear grayed out while files are offline. If you want to at this point, you can click the track's elastic audio plugin selector a second time to change from real-time processing to rendered processing. Elastic audio processors. Pro Tools provides 4 basic elastic audio processors. The option you select will determine how the audio on the track is processed. Each of the available processors uses a different TCE algorithm to produce its results, each tailored to a different type of audio material. It is important to select the plugin whose algorithm best matches the material on the track you want to process. The 4 basic elastic audio plugins can be used for either real-time or rendered processing. Each of the plugins is designed for a specific type of audio program material. The polyphonic processor is a general all-process algorithm that is effective with a wide range of materials. This is the default processor that Pro Tools uses for previewing and importing from workspace browsers. It works well for complex loops and multi-instrument mixes. The rhythmic processor is best suited to material with clear attack transients and rapid decays, such as drums and percussion. The monophonic processor is best suited to monophonic material that needs formant relationships kept intact, such as vocals. The monophonic processor is also well suited to monophonic instrumental lines, such as a bass track. The vari-speed processor links time and pitch changes for tape-like speed change effects and post-production sound effect uses. I use this less than the other three for corrections in music production. The XForm processor. The XForm processor provides advanced TCE processing and operates in rendered mode only. It cannot process audio in real time. The XForm Elastic Audio Processor comes with Pro Tools and provides much higher quality TCE algorithms than the basic Elastic Audio processors. XForm is well suited for professional music production, sound design, and audio loop applications. The XForm processor includes parameters for quality and formant options. The formant shape of a voice or instrument gives the audio its overall characteristic sound or timbre. XForm lets you preserve the formant shape of audio when applying TCE processing, helping protect it from the undesirable artifacts that often accompany pitch shifting. I'd recommend that you save time and use a real-time Elastic Audio processor while experimenting and fine-tuning your tempo map. Later, you can switch to XForm to obtain the best TCE quality possible once your tempo manipulations are complete. Understanding Elastic Audio analysis. When you enable Elastic Audio on a track, Pro Tools automatically analyzes the audio on the track for transient events. The waveforms temporarily appear grayed out as clips go offline during Elastic Audio analysis. Once the analysis is complete, the audio will come back online and the waveforms will appear normal again. Elastic Audio analysis is file-based, meaning that when you work on a clip, the entire underlying audio file is analysed. For clips from large files, this can take a while. As a result, small subset clips may be offline for longer than expected due to the processing time required to analyse the underlying parent files. Transient detection. Elastic Audio analysis detects transient events in each audio file and uses them to identify rhythmic events and patterns. Detected transients are tagged into the file and indicated by event markers. You can view and edit event markers using Analysis View, discussed later in this session. Tempo detection. Using the detected transients, Elastic Audio analysis attempts to identify a tempo for the analysed audio. Audio files containing a regular periodic rhythm can be successfully analysed for tempo. If the tempo is determined successfully, then Pro Tools will also calculate the file's duration in bars and beats. Analysed files in which a tempo has been detected are treated as tick-based files, meaning they contain timing information referenced to bars and beats. Tick-based files can be auditioned at the session tempo from a workspace browser. They can also be conformed to the session tempo map when imported or placed on an Elastic Audio-enabled track. Analysed files in which no tempo has been detected are treated as sample-based files. Files with only a single transient, such as with a single snare hit, will have no tempo detected. Also, files that contain tempo changes, rubato, or without regular periodic rhythmic patterns will probably not have a detected tempo and will be treated as sample-based files. Elastic Audio track views. Pro Tools provides two track views for Elastic Audio-enabled tracks: Analysis View and Warp View. The Analysis View lets you edit detected event markers. When you are working with audio that has clear, clean transients, you will ordinarily not need to use Analysis View. However, when working with material that does not have clear transients or material that contains transients for non-rhythmic events, you can use Analysis View to improve the results for certain types of TCE processing. Analysis View lets you add, move, or delete event markers as needed. Cleaning up the event markers can be useful to achieve better quality results from elastic audio processing and greater accuracy when conforming to a tempo map or quantizing with elastic audio. The warp view lets you manually warp audio to adjust the timing of audio events. In warp view, you can create and edit warp markers. Warp view is designed for using elastic audio to correct the timing of a performance or to achieve special effects. After applying an elastic audio processor to a track, you can change the track view to analysis or warp view at any time to edit the associated markers. To select an elastic audio view, click the Elastic Audio Enabled Tracks Track View selector. You can then select Analysis or Warp from the Track View Selector pop-up menu. Elastic Audio Markers. Pro Tools provides 3 types of elastic audio markers: event markers, warp markers, and tempo event generated warp markers. All 3 types are visible in warp view. Only event markers are visible in analysis view. In analysis view, you can add, delete, and reposition event markers. In warp view, you can add, delete, and reposition warp markers and use them as a control point for applying elastic audio processing. Tempo event generated warp markers, if present, are displayed in warp view only. However, you cannot directly move or edit tempo event generated warp markers on a track. Event markers. Event markers indicate detected audio events. Event markers are displayed as solid black lines in analysis view and as grey lines in warp view. Unlike warp markers, event markers do not fully extend to the top and bottom of the track. Event markers can be modified in analysis view if needed to improve results when processing with elastic audio. You can use the grabber tool to reposition event markers that have been added at the wrong place, or to add missing event markers or delete extraneous ones. You can add, delete, or move event markers in analysis view only. Warp markers. Warp markers anchor the audio to the timeline and are displayed in warp view only. Warp markers appear as thick black vertical lines with a triangle at their base and function similar to push pins, attaching the audio waveform to points on a time-based ruler. You can use warp markers to anchor or pin a point within an elastic audio clip to a fixed point on the timeline. When you pin one or more points on the timeline, you can use subsequent warp markers or event markers to stretch or compress ranges of audio relative to those fixed points. Warp markers can be added and modified in warp view. Existing warp markers can also be moved in warp view to apply elastic audio processing, warping the audio to which the marker has been attached. Tempo event generated warp markers. Tempo event generated warp markers are vertical grey lines with a diamond at the top that indicate where elastic audio processing has been applied to automatically conform audio to tempo events. They appear on tick-based tracks only and are not editable. If you change the track time base from ticks to samples, any tempo event generated warp markers will convert to regular editable warp markers, as the audio will no longer automatically conform to the tempo map. Warping sound with elastic audio. One very common application of elastic audio is to manually warp audio on one track to match another track, or to align with a specific timeline location. You will often need to warp a track to align with events on another audio track or with on-screen action in a video track. In these cases, you can manually warp an audio clip to speed it up, slow it down, or adjust the timing of audio events within the clip. Using warp view. To manually warp audio on a track, you will first need to set the display of the target track to warp view. For certain types of warping, you will also need to manually add warp markers to your clips. In order to display warp view, you will first need to click the Elastic Audio Enabled Tracks Track View selector. You can then select Warp from the Track View pop-up menu. Adding warp markers. To apply warping relative to fixed points in the waveform, you will need to add one or more warp markers to the target clips. As discussed earlier in this session, warp markers anchor points in the audio waveform to specific points on the timeline. Warp markers give you detailed control over warping for audio clips and events. To add a warp marker to a clip, do one of the following. With the pencil tool, click anywhere in the clip. If you click on an event marker, the event marker will be converted to a warp marker. With the grabber tool, Control-click on a Mac or Start-click on Windows anywhere in the clip. If you click on an event marker, the event marker will be converted to a warp marker. With the grabber tool, you can also click an event marker between existing warp markers or double-click on an event marker that is not between warp markers. The event marker will be converted to a warp marker. You can also add warp markers with the grabber tool by double-clicking anywhere in a clip in warp view. However, this method can result in the clip becoming selected, which can cause you to inadvertently move the clip when trying to drag a warp marker. I find that I do this all the time. Correcting warp markers. Adding warp markers to clips can be an imprecise operation, especially if you're not able to use existing event markers as warp locations. If you end up with a warp marker at the wrong spot, you can reposition it without warping the audio in the associated clip to fine-tune its location relative to the audio waveform. To reposition a warp marker without applying warping, do one of the following. With the pencil tool, click on a warp marker and drag it to a new location. With the grabber tool, Control-click on a Mac or Start-click on Windows on a warp marker and drag it to a new location. Deleting warp markers. If you have added a warp marker that you don't need, you can easily remove it from the clip by deleting it. If the warp marker has been used as a control point for warping, deleting it will release the warping applied at that point. To delete a warp marker, do one of the following. With the grabber tool, double-click on a warp marker. With the grabber tool or the pencil tool, you can also option-click on a Mac or alt-click on Windows on a warp marker. You can also select a range of warp markers to delete multiple markers at once. To delete all markers within a selection, in Warp View, make an edit selection that includes the markers you want to delete. You can then press Delete or Backspace on your computer keyboard to remove the markers. Alternatively, you can right-click within the Edit selection and select Remove Warp Marker from the pop-up menu. All warp markers in the selected range will be deleted. Types of manual warping. You can manually warp audio in one of three specific ways: telescoping warp, accordion warp, and range warp. Telescoping warp and accordion warp are used to speed up or slow down an entire clip, whereas range warp is used to adjust the timing of events within a clip. For music production, we mostly use range warps. Applying a telescoping warp. A telescoping warp can be applied to any audio waveform that does not contain warp markers. Telescoping warps can be applied to clips on both sample-based and tick-based tracks. The telescoping warp technique lets you click and drag an event marker in Warp View to stretch or compress the entire waveform of a clip relative to its start or end point. To apply a telescoping warp to a clip in Warp View, do one of the following. With the grabber tool, drag any event marker in a clip that has no warp markers. A warp marker will be created at the start of the clip, anchoring its position, and the waveform for the entire clip will telescope in or out relative to the clip's start location. With the grabber tool, Option click or Alt click and drag any event marker in a clip that has no warp markers. A warp marker will be created at the clip end, anchoring its position, and the waveform for the entire clip will telescope in or out relative to the clip end location. An accordion warp applies elastic audio processing on both sides of a single warp marker in a clip. This lets you expand or compress the audio equally on both sides of a fixed point. The audio warp technique is useful for audio files that have a downbeat in the middle of the clip. To apply accordion warp on a clip, first add a single warp marker at the point in the clip that you want to remain fixed on the timeline. With the grabber tool, drag any event marker on either side of the warp marker. The waveform for the clip will expand or contract on both sides, anchored on the warp marker. Applying a range warp. Range warps apply to elastic audio processing between two fixed points in a clip. To apply a range warp, you must have at least two warp markers present in the clip. Applying a range warp allows you to adjust the timing of audio events relative to one another. To apply range warp within a clip, first add a warp marker at the start point that you want to fix to the timeline. Add a second warp marker to the end point that you want to fix to the timeline, and then create a third warp marker between the first two warp markers and drag it to warp the underlying audio. The waveform will compress or expand on either side of the middle warp marker, while the audio outside the bounding markers remains unaffected. To automatically create warp markers from three adjacent event markers, shift-click on the middle event marker with the grabber tool. All three event markers will convert to warp markers, allowing you to easily apply a range warp with the middle marker. Using elastic audio to tighten a rhythmic performance. As an alternative to using range warping to manually correct the timing of individual notes in a music performance, you can use elastic audio to correct audio en masse within a selection by applying a Quantize operation. The Quantize functions let you align musical events to bars, beats, and subbeats based on the session tempo. Commonly used to tighten up MIDI performances, Quantization can also be applied successfully to elastic audio clips that have sufficiently accurate event markers. How quantizing affects elastic audio events. When you apply quantization to a selection on an elastic audio enabled track, the event markers within the selected range are used as control points for warping the audio. The event markers that are closest to the specified quantized grid are promoted to warp markers and are moved to the grid based on the quantized settings. As a result, the audio is warped such that any transients associated with those event markers are quantized to the grid, creating a more rhythmically accurate performance. Quantizing is particularly successful for audio that has clear, distinct attack transients correlated to a rhythmic grid or groove, such as drums, piano, guitar, bass guitar, etc. Quantization is less successful for audio that lacks rhythmic transients, such as strings, pads, ambient textures, and soft legato performances. Improving the quantization results. Although quantizing elastic audio provides a very quick way to correct timing issues, the results can often be less than perfect, either falsely quantizing events that are not rhythmically correlated, or degrading the quality of the resulting audio, or both. The root cause of these issues is typically excessive or imprecise event markers. For better results, you will need to clean up the event markers prior to applying quantization. This can be done by editing event markers in Analysis View and by adjusting the event sensitivity setting in the Elastic Properties window. Improving the quality of warped audio. As discussed previously, quantizing with elastic audio can produce undesirable effects if the audio contains inaccurate event markers. Other types of elastic audio processing, conforming, manual warping, and tempo changes, can also produce undesirable artifacts due to missing or unnecessary event markers. Editing the event markers in a clip for accuracy can make a significant difference in the timing accuracy and the audio quality resulting from elastic audio processing. To improve the audio quality further, you can switch to XForm processing after completing all of your elastic audio manipulations. Editing event markers in Analysis View. In Analysis View, you can add, move, and delete event markers to make corrections where Elastic Audio Analysis has not accurately detected audio events or has detected unwanted audio events. This can be especially useful for adding or positioning event markers in audio without clear transients, such as legato strings, melismatic vocals, or soft synth pads. To display Analysis View, first click the Elastic Audio enabled Tracks Track View selector and then select Analysis from the Track View selector pop-up menu. Adding and positioning event markers. You can use Analysis View to add missing event markers to Elastic Audio enabled tracks and to reposition event markers relative to the underlying audio waveform. To select an event marker, first set the track to Analysis View, and then do one of the following. With the pencil tool, click at the location where you want to add an event marker. With the grabber tool, double-click at the location where you want to add an event marker, or again with the grabber tool, you can control-click on a Mac or start-click on Windows at the location where you want to add an event marker. To reposition an event marker, first set the track to Analysis View, and then using the pencil tool or the grabber tool, drag the event marker to a new location. The event marker will be repositioned without affecting the underlying audio. Deleting event markers. Analysis View can also be used to delete unwanted or erroneous event markers on Elastic Audio enabled tracks. Eliminating unnecessary event markers can improve the quality of the audio processing. To delete event markers, first set the track to Analysis View and then do one of the following. Using the pencil tool or the grabber tool, you can option click on a Mac or alt click on Windows on the event marker you want to delete. With the selector tool, make an edit selection that includes any event marker you want to delete and press delete or backspace on your computer keyboard. Or with the selector tool, make an edit selection that includes any event markers you want to delete, right-click the selection and choose Remove Event Marker from the pop-up menu. The event markers will be deleted without affecting the underlying audio. Adjusting event sensitivity. Pro Tools uses very aggressive transient detection in order to detect every possible audio event. Consequently, for highly transient material, it is possible to have erroneously detected events. Each transient is detected with an identified confidence level. You can lower the event sensitivity to filter out erroneous events that have a low confidence level relative to more significant transients with a higher level of confidence. Understanding event confidence. Each event marker is assigned a confidence level based on the relative clarity of the associated transient. A drum loop that has clear, sharp transients will have event markers with a high degree of confidence, whereas a legato violin melody that has softer transients will have event markers with a lower degree of confidence. The confidence level for detected transients is based in part on the clarity of the transient. Loud, accented notes will be analysed with a higher degree of confidence than soft, unaccented notes. To change the event sensitivity, first select a clip on an Elastic Audio enabled track. The track can be either sample-based or tick-based. You can then choose Clip and then Elastic Properties, or right-click the clip and choose Elastic Properties from the pop-up menu. The Elastic Properties window will open. Click in the Event Sensitivity field and adjust the value as needed. In Warp or Analysis View, you will see the number of event markers decrease or increase as you lower or raise the event sensitivity. Using XForm. After completing your work on an Elastic Audio track, including making corrections to event markers, you can change the processor on the track to XForm for better quality results. When switching to XForm, the audio for the track will go offline while being rendered to disk. Remember that XForm provides rendered processing only. XForm processing can be quite time-consuming, so it is recommended to apply the XForm processor only after warping, editing, and tempo manipulations are complete. Any changes you make after applying XForm will cause the audio to go offline and re-render. If you have any questions, comments, or concerns about using Elastic Audio, you can contact me in the usual ways.